Okay, we are picking up in Unit 1, Lesson 3, Solving Quadratic Equations by Factoring. This is example 4, and we're going to look at how to factor a trinomial. So in part A, we have the problem x squared minus 2x minus 15 equals 0, and we need to solve it. So the first thing that we're going to do is we're going to look at our a, b, and c values. And from this problem, we should be able to see that a is 1, b is negative 2, and c is negative 15. So right here, we're going to write down a is 1 and c is negative 15. First thing you want to do is find the product of a times c. So over here, they have the answer is negative 15. From there, what you're going to do is you're going to write down all the different factors of negative 15. So one possible way that you could multiply two numbers and get negative 15 is negative 1 and positive 15. Negative 3 and positive 5 is another way. Positive 1 and negative 15 is another way. And positive 3 and negative 5 is the last way. And then with each of these groups of two numbers, what you're going to do is find the sum. So you're adding negative 1 plus 15, or you're adding negative 3 plus 5. And you're going to add up each combination until the sum is the b value. So b here was negative 2. So if you look at this, we can see, obviously, this pair is highlighted. It has a sum of negative 2. So our two factors that we're going to use are 3 and negative 5. 3 times negative 5 gives us negative 15, the product of a and c, and 3 plus negative 5 gives us the b value of negative 2. So the process that they write down here for this to explain how to get our two factors to factor the trinomial, it's a little bit more complicated than the process I would teach, but this is a process that you're going to have to use for problems that are more complicated, quadratic equations that are more complicated, and they become more complicated when this a value, right now it's 1, if the a value is not 1, then this is the process that you're going to use. But basically what they did is they took the b value of negative 2, and they're going to split it up into the two factors we found, which were 3x and negative 5x. So if you look at this first line and the third line, in the third line, 3x minus 5x is just negative 2x. So they're just rewriting the first line, but they're not actually changing the equation at all. From there, what you're going to do is you're going to group with parentheses the first two terms and the last two terms, and then you're going to find the greatest common factor of each pair. So in this first set of parentheses, you can see that they each have an x in common, so the x comes out. What you're left with is x plus 3. If you take one of these x's out, you're left with another one. You take this x out here, you're left with a 3. When you have that x plus 3 here, you can go ahead and automatically write x plus 3 again over here. And initially, this negative 5, that wouldn't be there. That would just be blank right now. And you have to ask yourself, what would I plug in? Sorry, School Max killed me. What would I plug in right here in order to, what number times x would give me this negative 5x? What number times positive 3 would give me negative 15? And hopefully you can see, if there's an x here, and this is negative 5x, that negative 5 would be the number that goes here. So then if you look at this group right here, the x times x plus 3, and then this other group, the negative 5 times x plus 3, you can see that each one of those has an x plus 3 in common. So we're going to take that out from each one. That goes here. And then the leftover stuff would be this x that's in front of the parentheses and the negative 5, which is in front of the second parentheses. And that gets its own set down here. So then, just like we did in earlier examples in this lesson, you're going to set each of these equations equal to 0. X minus 5 is going to equal 0, and x plus 3 is going to equal 0. Solve for each one, and you get your two answers of 5 and negative 3. And if you guys want to see the shorter way that I would solve these, just go ahead and ask me. And when most people have gotten to this point in the video, we can stop and I'll show this up on the board. Okay, part B. Here's one of those more complicated problems that the process that they used in part A is something that you actually have to do. There's no quick shortcut for doing this kind of problem. So we need to solve 5x squared plus 34x plus 24 equals 0. So again, what we're going to do is find the product of A times C. A is 5 and C is 24. So 5 times 24 gives us 120. And we're going to write down all the different ways we can get 120. And yeah, I realize this is a lot of different steps. But as you practice these more and more, you'll get better at this and you'll learn that some factors just don't make logical sense. For example, 1 and 120, if you multiply them, yeah, you get 120, but you should be able to tell before even finding the sum that these two numbers are not going to add up to anything close to just positive 34. So then we go down 2 and 60, that's 62 if you add them together. That's not what we want, we're looking for 34. 3 and 40, that gives us 43. 4 times 30 is 120, and that sum is 34. So that's the one that we're looking for, and all the other ones, hopefully you'll start with positive numbers and work your way the farthest two apart, and then a little bit closer, and then a little bit closer, and a little bit closer. And hopefully that'll give you the answer. But sometimes you're going to have to go through and write down all the different factors before you're able to find the correct pair that's going to give you the sum that you're looking for of the b value. So again, what we're going to do is we're going to take our b value of 34x and we're going to split it up into the two factors we found, which were 4 and 30. So 34x becomes 4x plus 30x. You're going to group the first two numbers. Then you're going to group the last two terms. If you look at the first set of parentheses and you think, what do they have in common? You should be able to see that the only thing they have in common is the x. They don't have any numbers. There's no number that can go into 4 and 5. So the only thing we can pull out, the greatest common factor, is x. We're left with 5x plus 4. So what we need to do, there's another typo right here. This is supposed to automatically also say 5x plus 4. So imagine there's a 5 in front of this x. The 6 is blank right now. Think about what number would I multiply by 5x to get 30x. And hopefully you can see that 6 times 5x will give us 30x. And then that also 6 times the 4 will give you the 24. So then we're going to look at this first set of numbers and this second set of numbers, and you should be able to see, remember this is a 5x plus 4, that each of them have a 5x plus 4. So you pull that out. The leftover stuff is x plus 6. That goes in front, gets its own set of parentheses. Then you're going to solve each equation by setting each one equal to 0. You'll get the answers of -6 and -4/5 when you solve each of those. Okay, here's a problem for you guys to check on your own. Pause the video. Remember, you need to find the product of A times C. List all the factors that give you that number, and then once you find the sum of one of the pairs that gives you your b value, that's the two numbers you're going to split -5x up into. So pause the video, solve the problem, come back when you're ready to advance to the next slide and see the answer. So our answer here is B. The x values are -1/2 and 4/3. Here's another one for you guys to check on your own. This is 3s squared minus 11s minus 4. Pause the video as long as you need. We're not finding the answers this time, we're just going to be factoring it. So you just need to figure out the correct factorization of this problem. And our answer here is A. This problem factors into 3s plus 1 times s minus 4. All right, example 5 is a real-world example about architecture. It says the entrance to an office building is an arch in the shape of a parabola whose vertex is the height of the arch. The height of the arch is given by h equals 9 minus x squared, where x is the horizontal distance from the center of the arch. Both h and x are measured in feet. How wide is the arch at ground level? Whenever you guys are looking at word problems, you're going to want to try to sketch a picture of what they're talking about. So somewhere in your notes, you should draw an arch, kind of following the pattern of my mouse right now. And it says that x is the horizontal distance from the center of the arch. So you might want to draw like the axis of symmetry that splits the arch or the parabola down the middle in half. and then x is going to be the distance from that vertical line to the end, to one side of your parabola. And if you don't understand what I was doing with my mouse there, just go ahead and pause the video and ask me to sketch a picture on the board, and I can show you a good picture to represent this scenario. So what we need to do, if we're going to find the width of the arch at the ground level, what we need to do is find the distance between the two zeros of the equation. So that means first we need to know what the two zeros of the equation are. So we're going to take our equation. If we bring this x, negative x squared, to the other side, it becomes positive. And if we bring the positive 9 to the other side, it becomes negative 9. So that's what they did here, just to get this. Effectively, what they did is they multiplied both sides by negative 1. Then we factor this. This problem, I think, goes back to example 2 or 3 from the first video. You should be able to see that this is a perfect square, x squared is a perfect square, and 9 is a perfect square. It's 3 times 3. So this is a difference of squares, x plus 3 times x minus 3. If you FOIL this out, you should be able to get back to this original part of x squared minus 9. Then we're going to solve each of these factors, and we get negative 3 and positive 3 as our two x values. So then you want to think about what's the distance between those two numbers. So the distance between negative 3 and positive 3, you can picture this on a number line, or the other way to find the distance between two numbers is to do one number minus the other number, or the right side number, the higher number on the number line, which would be the positive 3, minus the lower number, the leftmost number. So 3 minus negative 3 gives us 6 feet. So there's 6 feet between the two zeros. So then we want to think about how wide x would be. Okay, they just checked their answer there and made sure that the two answers were correct. Okay, so here's an example for you guys to check your progress. This one's about tennis. You're going to solve it the same way as the example right before this. So pause the video as long as you need. Come back when you're ready to figure out the answer and advance to the next slide. Okay, our answer here is 14 feet. Some of you might have noticed this. I noticed this when I was reading through the problem. When I have the equation 49 minus x squared, before we had 9 minus x squared, so if you think about the square root of 9, we had 3, and then we had 3 and negative 3, so the distance between those was 6, which is essentially just 3 times 2. If you think about this problem, 49, if we take the square root of that, 7, so we would have had 7 and negative 7. The distance between 7 and negative 7 is 14, which again is just the square root of this number times 2. 7 times 2 is 14. That's something I noticed, just a quick way to solve this problem. That's the end of the video. So go ahead and go back and look at other stuff in the video if you need to go back and review over it. But that's the end of Unit 1, Lesson 3.